Hello, this is question 18 on your November 2021 paper 2 from AQA, and you have two particles P and Q are projected at the same time from a fixed point X on the ground, so they travel in the same vertical plane. P is projected at an acute angle theta to the horizontal, speed u, Q projected with an angle 2 theta, speed to u. Both particles land back on the ground at exactly the same point y. Resistance forces to motion may be ignored, and we have to show that cos 2 theta is 1/8. So what is happening, and I'm going to do a very quick sketch. So we have two particles, one is projected with speed u, angle theta, and another with 2u, so double velocity and double angle, so 2 theta. But they are both landing at the same point, so they are landing, let's say here, this is point y, this is point x, and this one is just going to go higher, but then landed at u, at the same point y. Yeah. We have to show that. So if we consider the horizontal motion, because this distance is the same for both of them, we know that the horizontal displacement, I'm going to call it SH from horizontal, is going to be the horizontal velocity times by the time. Yeah. So if we consider P, for example, particle P, that will look like horizontal distance is going to be horizontal velocity is going to be the horizontal component, so the horizontal component of this velocity here, which is u cos theta, because it's adjacent. So this is going to be u cos theta times by the time. If we look at Q, we have that the horizontal component of the horizontal displacement is going to be the same, so these are the same. It's going to be the initial velocity, which is 2u, times by the cos to have the horizontal component, yeah, cos 2 theta, and the time is not going to be the same, and I know that's a common mistake for the people that did this question. So they are projected at the same time, and they arrive to the same point, but they are not going to take the same time. So we have two different times. We can call this TP, for example, and TQ. Yeah. So we can make these two equal because to each other. So we have an equation that says that u cos theta TP is going to be 2u cos 2 theta TQ. We can cancel u, but still to have too many unknowns. Yeah. We have to eliminate somehow the times and this cos theta. So what we can do is to consider now the vertical motion. If we consider the vertical motion for P, so I'm going to use the left hand side for P again. If we write subad and we consider, for example, up positive, the displacement from here to here, vertical displacement, is going to be 0. Initial velocity is the vertical component of this velocity, which is u, and opposite to the angle is sine, so u sine, and it's positive because I say positive is up. We don't need the final velocity. Acceleration is going to be minus the gravity, because I say positive is up and gravity is going to be down, so negative, and this is going to be TP. Yeah. So if I write a subad equation without V, it will be this one. So S is ut plus 1/2 at squared, and this one is the vertical displacement, yeah, which is not this one. This is going to be 0 is u, which is u sine theta, TP plus minus, because the acceleration is negative, so minus g divided by 2 TP squared, which means if I factorize this expression, 1 TP will be 0. Yeah, I can factorize. Give me a second so I can show you. So if I factorize TP and then u sine theta minus g divided by 2 TP, just factorizing, is going to be 0. So or TP is 0, or TP is, when I make this bracket equal to 0, is going to be 2u sine theta, 2u sine theta divided by g. This TP is the time that P takes, which is this TP here. Yeah, and now it's in terms of sine theta. So let's going to do the same here for Q. I'm going to do the same for Q because it's going to help us. For Q, if again I write suvat, but this time for Q, displacement is 0 because Q, the vertical displacement is 0 because it starts at the same height and finishes at the same height. Initial velocity is the vertical component of this velocity, so it's going to be 2u sine 2 theta, 2u sine 2 theta. We don't need the final velocity, acceleration minus g, because I'm again considering this positive, and this is tq, is the time that q takes. And I'm going to use the same equation. I'm going to use this one, so I'm going to substitute displacement is 0, velocity 2u sine 2 theta times tq minus g divided by 2 tq squared. I can do the same, so factorize, and I have 2u sine 2 theta minus g divided by 2 tq equal to 0, which means or tq is 0, so at the beginning of the motion, or tq is, I make this equal to 0, so I have 2 times 2u for u sine 2 theta divided by g. Yeah, this time is the time that q takes. So if I go to this equation that comes from making equal to each other the horizontal distances, and I substitute tp by this expression and tq by this expression, we have a few less unknowns. So let me show you. If I don't think I have a space there, no. So I have cos theta, times tp, and tp is 2u sine divided by g, so times 2u sine divided by g is going to be equal to 2 cos 2 theta tq, so 2 cos 2 theta tq, and tq is this expression here, so 4u sine 2 theta g 2 or 4u sine 2 theta, sorry, 4u sine 2 theta divided by g. So let's see what we can cancel. We can cancel g, we can cancel u with this u, these two with these two, and I have cos theta sine theta, cos theta sine theta equal to cos 2 theta of 4. I'm going to write the 4 at the front. So 4 cos 2 theta sine 2 theta. And I know that sine 2 theta is 2 cos sine theta cos theta. So we can write this as, I have cos theta sine theta is going to be 4 cos 2 theta, and using the double angle formula I can write that this is 2 sine cos, which means I can cancel this, and I can cancel because none of them are going to be 0. Yeah, theta is going to be an acute angle, so I know none of them are going to be 0. If not, be careful, because one solution could be when sine theta is 0 or cos theta is 0. And that means I have this 4 with this 2 is 8, so I have that 1 is 8 cos 2 theta, which means that cos 2 theta is 1/8. Yeah, and that's what we needed to prove. Be careful with these things. When you cancel and you have your variable in both sides of the equation, just check if this one equal to 0 could be a solution. Yeah. And that's it. That's this part. Okay. Then it says P takes a total of 0.4 seconds to travel from X to Y. So TP is going to be 0.4. And we need to find the time that Q takes. Yeah, so we can go back to this equation. Yeah, I think I'm going to use this equation. I know that cos 2 theta is 1/8, and even if you are not able to do this first part, you still know it, so use it, please. And then we can find cos theta with the double angle formula. Yeah, so we know I'm going to find first cos theta to use that equation. I'm going to use cos theta TP. So cos theta TP is 2 cos 2 theta TQ. 2 cos 2 theta TQ. So I already have that equation. I know now TP, I need TQ, I know cos 2 theta, so I'm going to use the double angle formula to find cos theta. So I know cos 2 theta is 2 cos theta minus 1. Cos 2 theta is 1/8. This is cos squared. 2 cos squared minus 1, which means that 2 cos squared is going to be 1/8 plus 1, which is 9/8. So cos square theta is 9/16, and cos theta is going to be plus minus 3/4, but both angles are acute, so they are in the first quadrant. If they are in the first quadrant, cos is going to be the positive one. Yeah, so I'm going to pick the positive one. Theta acute. Yeah. And now I can go here and substitute again. So if I go there, let's say this is 1, and I am here, back to 1. Cos theta is 3/4. TP is 0.4. They just told us 2 times 1/8 is given times TQ. And from here, very quickly, we get that TQ is 1.2 seconds. Yep. And the next thing, and the last one, is state one modeling assumption you have chosen to make in this question. So one common thing is when you have projectiles, is that we are considering that our ground is flat, so the height of this point is the height of this point. That's where we say that displacement, vertical displacement, is 0, but that's an assumption. That's something that in real life is unlikely to happen. Yeah, usually ground is not completely flat. So I would just say that we are assuming that x ground is flat and x and y at the same level, or are at the same level. Something like this. You can explain with your own words. That is what we are assuming, actually. Yeah, and that's all with this question.